Welcome to Advanced Traction Control Part 2. We're going to start off with steering sensors. They are pretty much what the title would suggest. They're used to measure the amount and speed of rotation of the steering wheel. They typically are potentiometers or Hall-style sensors that are used. Sensors are hardwired to a module, can be on a data bus. This is just sort of general knowledge here. And if you're not sure, always consult a wiring diagram to determine the sensor configuration and the reporting module so you know where to go to look up your data on a scan tool. Here are a couple of examples. Just like our accelerometers, we've got a couple of different types. On the left is a wiring diagram from a Ford. You can see the steering angle sensor module. It is a modular sensor, power and ground, and a couple of data lines going into it. And on the right, we have an analog sensor. So this guy would require power and ground, and then it has two output type circuits or two sensor circuits, sensor 1 and sensor 2. So this guy's hardwired to the module. This guy is wired directly on a data bus. And as far as operation goes, it makes a difference where you go looking for it with your scan tool, but internally, they're probably very similar. So this is some scan data from an older car. It's an 01 DeVille, and all we did with this car is we're just turning the steering wheel back and forth. There's nothing wrong with this car. You can see the two sensors as I turn the wheel. They track very nicely back and forth, no sensor dropouts, that kind of stuff. And down at the bottom, you can see the steering sensor output as a percentage. So as you turn the wheel, that percentage should creep up and down and go positive and negative. Obviously here, we've got a problem with this sensor. Again, some simple wiring checks here. If they check out, you're going to replace the sensor on this thing. This car would be setting codes. It may have some steering issues, steering going light, steering going heavy, that kind of stuff. Would probably turn the traction control light on, set a trouble code. So here we're looking at steering wheel angle data, again, this time from a GM, but we're looking at just the steering wheel angle. Typically, if the car is going straight ahead, you should see close to a 0-degree turn. And as you turn it left or right, the angle should go up positive or negative depending on which way you're turning the steering wheel. As far as testing goes on this guy, let's say the yaw sensor and the steering angle sensor don't agree, or you're driving the car straight ahead and it's showing you're 30, 40, 50 degrees to the left or right. Obviously something's haywire. So for testing the sensor, more or less you're just going to go in and test it for powers and grounds. Maybe throw a scope on it, rotate the sensor back and forth by turning the steering wheel back and forth. And what you're looking for on the scope is a nice, easy, voltage going up, voltage going down, just like what we're seeing here on this scope shot. Obviously, the top trace is a good sensor. The bad one, or the bottom one, is bad. Therefore, this vehicle would require a steering wheel sensor. Driving the vehicle, drive it straight ahead. This time we're using a scan tool. But basically, whatever you're doing with the steering wheel angle should agree with you. If you're driving the vehicle straight ahead and the steering showing 180 degrees or something like that, then there's obviously something wrong with the sensor, and you can test it like we did on the previous page. Now, when it comes time for replacement, a lot of these sensors require calibration. Sometimes it's manual, where the sensor comes with a locking pin in it to hold it in a certain position until you bolt it into the car. Other times you have to go in, get the steering wheel pointed straight ahead, then run some kind of a calibration routine with the scan tool. So the bottom line here is always consult the service manual on any vehicle that has stability control for procedures. Some cars even require adjustment after you do an alignment or a tow set, or replacing components like control arms and tie rod ends and that sort of thing. So bottom line, or best practice here would just be to go to the service manual and read ahead as to what your car is going to require before you go ahead and release it back to the customer. Now, brake sensors come in a couple of different styles, but typically the system needs to know how hard the brake pedal is being pushed. So some of the systems watch a pressure sensor to determine how fast the brake is being applied and at what level. Other systems use stroke sensors. Some use a couple of switches, but you know, there's a couple of different things they can do here. But a lot of these systems now have the capability of isolating the driver and braking the car electronically without too much input from the driver in a panic situation. So brake sensors don't have to be located in the hydraulic unit. You can see the one on the left is, the one on the right is in a tap off one of the pressure lines coming off the master cylinder. These are just 3-wire pressure sensors, and typically the brake pressure can be read on a scan tool. So for example, on this GM, the brake is on. We've got our foot pushed down on it, and we're showing 109 psi of pressure being applied. And here are a couple of other brake sensors. The one on the right is just a potentiometer, kind of like a throttle position sensor. And the one on the left is a MUX switch with a couple of different resistors in it. And then moving on into torque management, all systems today incorporate some form of torque management. This means that the traction control system is in charge of how much torque the engine is allowed to produce. When traction control is requested, the ABS module acts at PCM to reduce torque. The PCM will then close the throttle. The instrument cluster will display a traction control active message or flash the traction control light, depending on how the manufacturer chooses to do that. And obviously, this is to alert the driver that a power loss is due to traction control, not anything wrong with the vehicle. Communication typically handled one of two ways: a direct serial line between the traction assist controller and the PCM. They don't use this much anymore. General Motors used this a fair bit in sort of the mid to late 2000s. And then everybody kind of went away from that, and the traction controller is now just part of the main data network, and it's just another module on the bus so that it can communicate directly with the PCM if it wants to, but it's also communicating with other modules as well. So this is a direct serial communication setup. Typically, you'll find this on GMs. We've got 2 hardwired inputs going back and forth between the PCM and the brake controller. We've got the requested torque. This is how much torque the ABS module is requesting from the PCM. And then we've got the delivered torque, what the PCM is actually delivering. So these are my 2 torque management circuits. The third wire here, the serial data wire, is for scan tool communication between the 2. So scan data, note that the torque signals are on the regular data stream, even though they are separate signals. The ABS traction control module communicates directly with the PCM for traction control functions. Typically on a GM, this would be class 2. Sorry, the ABS traction control module communicate with all other modules on class 2. However, ABS to the PCM on some of the older GMs is a dedicated 2-wire traction bus. Kind of works like this. The traction control module supplies 12 volts for the torque delivered signal. The PCM grounds the circuit to send information, and the torque requested circuit, the powertrain control module is supplying 5 volts, and the brake control module is tapping that to ground to send out its signal. So that on a scan tool, basically what you have is 2 signals kind of working in conjunction, which can be read on a scan tool, which is the best way to look at it. And as you accelerate and decelerate, these 2 will kind of change positions a little bit. But these are typical signals from a known good vehicle, nothing wrong with the car. Okay, but it's just an example of what these things would look like on a scope. However, before you go scoping them, probably just easier to go ahead and take a look at them on a scan tool. And you can see on my example here, I have the torque delivered at 41 and the torque request at 448. Or put another way, torque request at 75 foot-pounds, torque delivered 75 foot-pounds. Now this car is obviously in some kind of torque reduced mode because I've got my throttle all the way to the floor and the throttle position angle is only 19. So this will be a case where the PCM has throttled the car back, probably because of wheel speed, wheel spinning up or something of that nature. Now we know that most late model vehicles don't use that type of serial communication anymore. So most late model vehicles are using just a standard high-speed network, CAN bus, that type of stuff, just like any other module. With CAN buses being as fast as they are, you can move information around fast enough to do the job. But the nice thing about the newer stuff is the PIDs are still there, and the system works primarily the same, but instead of having direct serial lines, we just have data buses to move information around. As an example, I'm just driving this car around the parking lot. We're looking at a couple of things. We're looking at our lateral sensor, engine torque, that kind of stuff. And all I'm doing basically here is driving the vehicle around a little bit in a parking lot. Now, this is a snow-covered parking lot, but I'm not doing anything with it right now other than just sort of driving it slowly around. And here, there's no cutback on torque or anything like that. Here, however, I'm basically floorboarding the thing, trying to goof it up a little bit. We see that the G sensor, the acceleration sensor, kind of sees that, and then the vehicle goes into managing torque. So torque is cut back on it. So this is just kind of an example of me goofing around a little bit, trying to mess this car up. There's nothing wrong with this car. It's doing exactly what it's supposed to, but just thought I'd show you some different things here with scan data. And then finally, I'd like to finish up this class with a little bit of a case study here. This is a 2015 Dodge Ram 1500. It's got a traction light on and a U0415 code stored in it. And this vehicle has been in a front-end collision, so that's kind of important. Now, when we go in and start looking at the codes, the U0415 is an implausible data message received from the ABS. And then we've got some other codes here. We've got a steering wheel position sensor problem, steering angle sensor, angle over travel performance, steering wheel position sensor, internal electrical failure. Well, I think for the time being, because we've got a bunch of C codes in this thing, we're going to ignore the U0415 and see what's wrong with the steering angle sensor. So this is just sort of a blurb that I pulled out of, I believe it was ALLDATA. They talk about this has got an electric power steering gear in it. It talks about the steering wheel position and rate of movement from the steering angle sensor, steering wheel torque from torque sensors in the EPS, electronic powered steering gear vehicle, in the EPS or vehicle electronic power steering gear. And then it has a kind of a highlighted paragraph here that says no components of the EPS system can be serviced separately. If any component of the EPS requires service, the entire steering gear must be replaced. The only serviceable parts are tie rod ends, that sort of thing. So our EPS module location looks like, according to this diagram and the verbiage here, that everything is sort of built into the steering gear on this thing. So when we go in and take a look at the steering wheel position sensor, we see some diagnostic stuff here. It's a continuously run DTC. The anti-lock brake system detects a steering angle sensor over travel of 720 degrees, and then they give you some possible causes: steering wheel alignment, steering column or intermediate shaft, steering angle sensor, steering control module, or the ABS module. It's a pretty wide list of things. So when you start to go through the trouble tree here, it says check for an active DTC. Is it active? Yes. We can clear it, but it comes right back. Then it says go to step 2, inspect the wheel alignment, steering column, that kind of stuff. Check if the vehicle was in a collision. Well, ours definitely was in a front-end collision. And then it says yes, repair is necessary. So yes. Sorry. Were there any repairs required? Well, no, everything kind of looked pretty good on the outside, nothing physically damaged or any of that kind of stuff. So then we're directed to go to step 3, which is check the steering angle on your scan tool. So turn the steering wheel so the wheels point in straight ahead position with the scan tool. Is the steering angle within 15 degrees of 0? Well, when you look at our steering angle, it's sitting there at 640 degrees. So it's definitely way off. And then from there, we're told to go to step 5. Step 5 says check the clock spring installation. Proper clock spring installation is crucial for proper operation. Turn the ignition off. Verify that the clock spring SAS is properly installed. And then just following down the page here, is the clock spring SAS, I had to look that up, that steering angle sensor properly installed. And if it is properly installed, it tells you to replace the steering column control module. So the service information in this section of the trouble tree tells us that the steering angle sensor is part of the steering gear, and the trouble code wants us to replace the steering column control module. Well, those appear to be 2 different parts until you go into Chrysler and look this whole thing up, and the entire assembly, including the clock spring in Chrysler service literature, is referred to as the steering column control module. So in order to replace the steering angle sensor on this thing, which it needs, we're going to have to replace the steering column control module. And that brings us to the end of our advanced traction control and stability control module. Hope you guys enjoyed it, and we look forward to seeing you at our next video.